Hey, Night students, here we go. We're going to start. It's time to go. The Jovian planets, the gas giants. We're moving out in the solar system. We're moving up. We're moving out. Here we go. Jupiter is up first. The biggest, the baddest is Jupiter. And look, if you see on the screen, it's a cute dolphin, right? No, that is an interesting storm. It was a meme a little while ago that does human see patterns in things. That's not really a dolphin. That's fine. But here we do know Jupiter is the largest planet. It is a gas giant. It's huge. It is the next brightest thing in the sky. Remember how I talked about this? So the sun, the moon, Venus, Jupiter. Jupiter is significantly farther away than Venus, and it's the next brightest thing in the night sky. After Jupiter, things get a little funky because it's Mars, but it depends on if Mars is close or Mars is far away. And then it's Sirius, a star, but it depends on the other planets depend on whether they're close or far away or where they are in the sun because their brightness varies. But it is Sun, Moon, Venus, Jupiter. Next brightest thing in the sky. Nice and crazy. Here we go. Let's start. Let's get some perspective here. Some things to notice. If this is everything, Mercury, Venus, Earth, Mars are all nice and tight spirals in there. Then you've got an asteroid belt, and then we space out. The gas giants are really, really far apart, okay, from solar system perspective. Jupiter is the second most massive thing in the solar system. It's the sun and it's Jupiter, and together they combine like 90 or 99% of the mass of everything in the solar system when you combine the two. All right, here we go. It is the third brightest. Here's where we are. So Jupiter is inside Saturn. Jupiter was Galileo, all right? The Galilean moons, Io, Europa, Ganymede, and Callisto. Io, Europa, Ganymede, and Callisto. Here we go. These are not necessarily those four, but this is a view from the Earth through a telescope. You can, from a telescope on Earth, you can see the bands. This is the Hubble Space Telescope. So also from Earth at a distance to Jupiter, this is Cassini, when Cassini went flying by Jupiter. So the images have improved over time and with location, the closer you are to Jupiter. But some things to notice. Very obvious, very striped. Those are all parallel to the equator, those bands that go around there. We've got the infamous Great Red Spot to talk about. And lots of storms and things going on. All right. So we saw the dolphin. They're parallel. All right. Simple properties. Jupiter is 318 times the mass of Earth. 318 times the mass of Earth. The radius is 11.2 times the mass of Earth. Better yet, by volume, if you hollowed Jupiter out and stuck it full of Earths, 1,400 Earths would fit inside of Jupiter. All right, Jupiter, its density is a little more than water, but it's not much more than water. It's 1,100. Jupiter is 1,300 kilograms per cubic meter. And you're like, I don't get that. Well, water's 1,000, okay? But Earth's overall density is 5,500. So Jupiter is less dense than Earth because it's not made of dense, heavy, rocky material. All right. Jupiter is mostly hydrogen and helium. And the most critical, the weirdest, the most unusual thing, there is no surface to Jupiter. None. Okay, it's not that if you go down far enough below the clouds, you just go down, and then as you dig down in, no, there is nothing. Nothing. Okay, so let's talk about these bands a little bit. These bands are flying around there. Earth takes 24 hours to go around. Well, these bands, under 10 hours. And remember, Jupiter's bigger. Fastest rotation thing in basically the solar system, all right? It's differential rotation because the equator and the poles don't rotate at the same rate. It's slower at the poles than at the equator. That's differential rotation, all right? Now, these are cloud tops. So there is no solid surface. There's no solid surface. But what about the inside of Jupiter? How do we know what the inside is? It still? Is it rotating? What's it doing? So looking at Jupiter's magnetic field, it's about 10 hours. We can observe that it's rotating. All right, so that the poles probably match the interior. 9 hours 55 minutes. All right. The magnetic field, 14 times stronger than the magnetic field on Earth. Okay, significantly stronger. All right. Here we go. What happens when we rotate that fast? That's 2A. Here we go. What happens when you rotate that fast? Little pudge in the middle there. It's an oblate spheroid, which is Earth. This happens a little bit on Earth, but Earth is a solid, so not a lot. This happens a lot on Jupiter because it's a gas giant. If you're not rotating, gravity pulls in, heat and pressure push out. It's a nice circle. It's a nice sphere. But as you're rotating, there's a force near the middle. Not a force. There's no such thing as centripetal force. That's for physics class. Come take physics. But the things rotating on the equator want to go in a straight line, and it takes more gravity to pull them around, and the gravity isn't stronger, so they orbit in a bigger circle. So there's a bulge in the middle. Fine, no big deal. But Jupiter's fairly flat, or flattened. All right. The Great Red Spot. How big is the Great Red Spot? We don't have a picture near here for that. Great Red Spot, twice Earth. Okay, this thing was observed in the late 1600s. This hurricane is at a minimum hundreds of years old, and that's all it is. It's a giant, well-formed, continuous hurricane twice the size of Earth. The Great Red Spot's a thing, and it's really just an interesting feature that we know about on the surface of Jupiter. All right, to orbit here, the gas on the edge takes about 6 days to go around there. So it's moving fast. Well, wait a minute. To go all the way around the Earth and then something else, make this size trip in 6 days, that's pretty quick. All right. 86% of Jupiter is hydrogen. 13.8%, give or take, is helium. 0.2% is everything else. What are those everythings? Methane, ammonia, water vapor, all sorts of other stuff going on Jupiter. All right? That's where these colors come from. Not that ammonia gives you kind of a yellowish, but where do the pinks come from? They think it's really weird chemical interactions on Jupiter. Okay. Belts and zones. Belts are bright. No, I said that backwards. It's not alliterative. Belts are dark, zones are bright. It's a bright zone. Zones, the reason they're bright when you look around the edges of this is because they're actually elevated up. There is warm air rising, there's higher pressure, and the cloud tops are higher than these lower belts over here. All of this is circulating. Here's the other thing. If you look at the wind pattern, this is the craziest thing. Inside the belts, wind flows to the east, inside the zones to the west. So if you think east wind, west wind, east wind, west wind, that's a crazy pattern. But the clouds are rotating so fast. These are like low and high pressure, but they're rotating so fast that instead of having a front like we see on Earth, a low pressure region coming in, they've stretched all the way around the planet. So their low and high pressure regions are kind of spread out that way. That's why they're much more consistent and evenly distributed like that. All right. Here we go. Elevation. We got the elevation. So this is a picture. If the line is near here, the wind is not going. So here the wind is blowing to the east. Here the wind is blowing to the west, 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 east, 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 east. That's what's going on. So the wind goes east, west, east, west, east, west as you move across these zones and belts. So that's kind of interesting. It really cuts quickly from one direction to the other. Okay. There is no solid surface. There is no solid surface on Jupiter. So where do we call the atmosphere and where do we call the inner planet? It's right here. Zero altitude, what we can call zero altitude, is the top of the troposphere. The troposphere is the weather layer on Earth. So where the weather happens, where there's convection, where there's warm air, where the clouds are, the top of that is zero. So on Earth, that would actually be up in the air and the ground would be down here. But since it's clouds all the way down, they're just going to call the top of this zero. So this is up in the atmosphere. So altitude goes 0, 50 kilometers, 100 kilometers. So this negative 50 just means 50 kilometers down. You've got all these different chemicals. The temperature is increasing as you move into the core. That does say water ice. That just means in clouds there are sleet pellets, if you will. Okay? There's no solid surface, but if you keep going down, 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 all of a sudden it's a liquid. You're like, if there's a liquid, isn't it an ocean? You go from air to ocean. No, because this is more like you're standing in the clear and then you walk into a little fog and then you walk into a thick fog. And then if you've ever been running or driving and the fog is so thick and dense that there's like condensation forming on your windshield or on you. And then it's thicker and thicker, or think like if you've ever been in a pool and it starts raining, and so you're half of you is submerged and the other half is just wet, and like you can't really tell. Like it's so gradual that the fog is getting thicker, 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 wetter, 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 and then this just solid. Then you're just in water. There is no solid surface. There is no immediate sudden transition from air to water. It just gradually gets thicker and thicker and turns more liquid as you move towards the interior of the planet. It's weird. All right. Okay. Jupiter gives off more energy than it absorbs. So where does that come from? Well, here's the thing. When Jupiter was forming, all these spinning parts, they collapsed in on themselves. So you're taking potential energy as it falls in and it turns to thermal energy and it heats up. That heat from way back when Jupiter formed is still slowly leaking out, and Jupiter is giving off more energy than it gets in from the sun. And it all comes from gravity years ago. Here we go. Depth of 100 kilometers. So the temperature is 300 Kelvin. The temperature is going up and up and up. This would be the planet's interior. 20,000 kilometers, 60,000 kilometers. The icy, rocky core. When that says rocky, it does not mean solid rock. What it means is this liquid or cloud, or think almost that's made of different metals and different rock materials, made of carbon and stuff, instead of being made of hydrogen and helium. Think of the molten core of Earth, which we haven't talked about yet, is not a solid rock, but it's made of molten iron, right? So as you move down in here, don't think of a cold cloud getting thicker and thicker and thicker. It might be a hot cloud getting thicker and thicker. As you move in, the temperature does go up. All right. That's the interior. All right. Magnetosphere. Oh my gosh. Jupiter's got a really strong magnetic field. This is the path of Pioneer. Jupiter's magnetic field, every planet's magnetic field gets this weird teardrop shape away from the sun because the sun is blowing particles out to it, and the magnetic field does that, and this shields everything. Its magnetic field goes out past Saturn. Huge, huge influence of the magnetic field of Jupiter, okay? We could talk about the Taurus and different things in a minute, but that's the magnetic. All right, the aurora, northern lights, aurora borealis, southern lights, right? This is similar to what's going on Earth. The magnetic field drives that. Okay. 79 moons. 79 moons around Jupiter. Io, Europa, Ganymede, and Callisto. Io, Europa, Ganymede, and Callisto. Those are the 4 Galilean moons because Galileo discovered them with his telescope. Not his that he invented, but the one he was the first guy to really look up and explore with the telescope. Io, Europa, Ganymede, and Callisto. We saw the picture at the beginning of the chapter where they were visible near Jupiter. Okay. There are over 79 moons, 53 named right here, 79 moons. Pretty pictures. Io, Europa, Ganymede, Callisto. All right. Io, that weird pizza looking color thing. Io is the most volcanically active object in the solar system. Period. There's a lot of stuff going on, okay? So it's the most geologically, I shouldn't say volcanically, geologically, because there's plate tectonics, there's geology, there's all sorts of stuff moving on but there's no craters. There are very few craters. Why? Because these things explode. They come off of there. They erupt continuously. We don't need the magnetic field. They erupt continuously, and they fill those craters back in. That was the four moons. Io, Europa, Ganymede, and Callisto. And here we go. We're going to get Io. Two more. We're going to show you that. This is a picture taken by a traveling passing satellite. That's a volcanic plume going on. Okay? 1 second. All right, we're back. Here we go. We've got volcanoes and their plumes coming off. These don't ooze lava like they do on Earth. They eject lava. This volcano right here, this insect, this is Loki. So Thor's brother. Yeah, Loki. There's so much going on this planet. It changes where the volcanoes are. It does not have necessarily its own molten core and its own geology. It is so close to massive Jupiter that as it goes around, it tries to sync up in orbit with Jupiter, and then it passes another moon, and it gets twisted and turned and pulled, and it can't get into resonance, and that bends and moves and breaks the crust and causes it to heat and remain active. All right? That's Io. Europa. Okay. Yeah, that's the Io still. Europa. Do you see all those lines? All those cracks, all those crusts there? Europa here. You can see these canals. They're not canals. Ice fishing. Europa is the largest moon in the whole solar system. It's bigger than the planet Mercury. And our best understanding is that it's ice fishing. That is water ice, frozen solid all the way around the crust. And if you drilled down through it, there would be liquid water underneath. It's completely wild that is H2O and then possibly salt water or, briny water underneath. There's no telling. People who are looking for aliens, people who are worried about that, or that's the spot within our solar system. That's probably the most likely spot. But, well, we're biased because we think everything needs water, right? That's the place with the next most water, more than Earth's oceans, on Europa. Ganymede and Callisto. Ganymede and Callisto are kind of twins. Really, really, really similar. Not necessarily ice over liquid water, but just frozen solid ice, kind of top to bottom. All right, Ganymede and Callisto, ice throughout. Nope, I lied. Europa is not the largest. Ganymede's the largest. Ganymede is bigger than Mars. Europa is just strictly ice fishing. Ganymede's bigger than it's larger than Mercury. There we go. See, it even says so on this website. I don't have to look. All right. Ganymede and Callisto are both frozen. They are both ice. Now, we got just a couple things. I want to show you one more. I want to show you Valhalla. All right. This is on Callisto. Not there. $24. So that was a long way off. Valhalla is a low area there. Do you see all those circles going out from there? All those wrinkles? Something came in and smashed that a long time ago. and wrinkled the whole thing. That is a massive impact to do that to ice and rock like that. So that's impact. That's on Callisto. It's kind of interesting. Last picture. Here you go. That's a ring. Saturn is not the only planet with rings. All the outer planets, Jupiter, Saturn, Uranus, Neptune, they all have rings. Saturn is just the one we think of. Jupiter, Saturn, Uranus, and Neptune all have rings. Jupiter has like literally one. Saturn's the most prominent, it's the most prevalent. It's very cool. But this is Jupiter. Biggest planet in our solar system. Whole lot going on for it. Lots of moons, active moons, giant moons. It's massive. It's Jupiter. Everybody, you guys have a